We talk next about the function y equals e to the x. We've used, well, no we haven't, okay. Y equals e to the x. E is the most natural base for the exponential function. We could talk about y equals a times b to the x, y equals a times 2 to the x. These are also basic forms of exponential functions, but y equals e to the x, or y equals a e to the kx, it's going to turn out, are the most appropriate for calculus. This is because this function, y equals e to the x, has a very simple derivative. The derivative of y equals e to the x is just dy dx equals e to the x. The function is its own derivative. And we'll see what that means and why that happens later. E is a number that for now you can consider just to be approximately equal to 2.7. There are a lot of other connotations to E and a strict definition in terms of limits, and we'll see that definition later. But for now we can just think of E as a number between 2 and 3, somewhat closer to 3. To see where the graph of y equals e to the x lies, we first graph y equals 2 to the x, and then we graph y equals 3 to the x. Y equals e to the x is going to lie in between these and somewhat closer to y equals 3 to the x. Just as we turned the 10 to the x function around to get the logarithm function, we're going to use y equals e to the x to define what we call the natural logarithm function. Remember how we can get the graph of the inverse function of a function by reflecting across the y equals x line. And if we reflect this y equals e to the x graph across here, we see, for example, that the point 0, 1 on the graph of y equals e to the x, e to the 0 is 1, any number to the 0 is 1, is going to reflect over here to 1, 0. This point has some real significance. At x equals 1, the value of this function, y equals natural log or ln of x, goes from negative to positive. So for x greater than 1, natural log of x is positive. For x less than 1, it's negative. And it goes on and it's asymptotic to the y-axis. There's no limit to how large these negative values can become. The most basic definition of the natural log function is that the natural log of x equals c is equivalent to saying that e to the c equals x. This is just a statement of the fact that the natural log is the inverse function of the exponential function, because you see we've simply we switched the roles of c and x here. C is over here, x is here, as we go from exponential to logarithmic. But this is a statement that you should know and be able to apply anytime you need it.